When we take a network, there are a lot of devices involved in it, also design involved in it. So the requirement is not just the hardware or a software, it is also design. Design matters. If you don't have proper design, for example, aeroplane, if aeroplane is in a square shape, what will happen? It cannot fly. If your car is in a square shape, can you go fast? No, you cannot go fast. So there is something called aerodynamic. So you need to design an aeroplane or this car to fight against the repulsion, the resistance which we have in the atmosphere. The aerodynamic needs to be there so that it can easily go smooth through the wind, through the atmosphere. Likewise, for smooth communication, for good communication, when I say good, it includes fast and reliable, no latency, no jitter. Such network we need. For that, proper design is needed. Good design alone can promise you good quality of service in the network. So we are going to understand the network requirements, including the design part. We see different type of network enterprises, campus network, data center of the network campus, branch office, and then some teleworkers like remote access, meaning you work from home, no? They're called as teleworkers, working from home. So what you need is a VPN to work from home. You cannot use normal internet to do your office job. Why? Yeah, you are going to use normal internet, but on top of it, what you're going to have is VPN. You will VPN to your company, to your campus, to your branch office, or to your data center. And then through your VPN only you will work. Do you understand, Thiru, what I'm saying? Without VPN, you cannot do work from home. They won't allow you. You need to first do VPN to your company. Using the internet that you already have, you need to have a VPN connection, virtual private network connection to your office. Through VPN only you can have a secure communication. That's the reason why we need to do VPN. See, we have different type of communication from and to an enterprises. What is an enterprises? A company is an enterprises. If you are running a company, your company's network is called as enterprises network. Some companies are very big, some companies are small. Big companies will have many branch office, data center, teleworker. Small company may not have all this. So we are focusing on a medium to big size network in this chapter. That's what we call as enterprises. So this is the well-known popular network model, network design that Cisco recommends. This is well known and very popular. Recently, we have another model which is called leaf and spine model. We will discuss on those things later. But now, the popular model, the well-known model is this: three-tier architecture. Three-tier, three layers you see. Below you see access, the red color. Then the distribution layer, and then the core layer. If you see all the end device, locally connected device like computers, PC, laptops, printers, all they connect here. Not only that, if you are doing from home, if you're working from home, to this layer, you do VPN. This is where you have layer 2 devices, switches. Lot of switches with multiple VLANs and a spanning tree running in this layer. And these switches are connected to some routing devices on the top, where the policies are applied. What policy? Routing policy. What is routing policy? Decisions how the packet should be forwarded. The path selection. The policy based. That's for distribution layer. We have access layer. To access layer, you connect all the end device. In the access layer, you don't have routing. Members of same VLAN, they communicate using the switch. The traffic never goes to distribution layer if the traffic is moving in between the devices that are in same VLAN. Only when you try to communicate from one VLAN to another VLAN, the traffic will go to distribution layer. That is why we call it as distribution. It distributes the traffic from one network to another, from one VLAN to another. Distribution layer. Distribution layer is the place where we apply the policies. Policy. Policy-based routing. You might have heard about this word, policy-based routing. Now, where is this policies applied in our network? Distribution layer. Those routers that are in the distribution layer will forward the packet according to the policy that you have applied. Even if you don't have policy, still this layer is called as distribution layer, where the routing happens. Routing won't be done in the access layer. Access layer is only layer 2 communication. Members of same VLAN will be able to communicate. See, because I say layer 2 communication, you should not think that we don't need an IP address. IP address is needed to identify the device Then why we call it as layer 2 communication? Because the switches are involved. There is no routing involved. Switches, they forward the packet based on MAC address. But you want to ping someone, you will use only the IP address, not the MAC address. So using the IP address, you generate the packet. Using the MAC address, the switch forwards the packet to the destination. So whether you do layer 2 communication or layer 3 communication, both IP address and MAC address are needed. Now, for layer 2 communication, you need only switches, and we call it as access layer. Whenever I want to communicate from one layer, one LAN to another LAN, one layer 2 domain to another layer 2 domain, the traffic will go to the distribution layer. In the distribution layer, the routing decides the destination VLAN. So distribution layer is routing, access layer is switching. Distribution layer has got multi-layer switches, routers, where we apply the policies using ACL, access control list, or policy-based routing using policy maps. And there are many more things, where you can write policies. So distribution layer is routing, access layer is switching. Communicating from one VLAN to another VLAN, is it routing or switching? Communication between one VLAN to another VLAN, is it routing or switching? Yes, routing. Only for routing, the traffic will go to distribution layer. If the communication is between the devices of same VLAN, then it will be local switched in the access layer. The traffic will not go up. So, if you use the design which is prescribed here, you can have load sharing. Not all traffic is going to be processed by all the device. Not all traffic will be processed by all the device. Distribution layer process only the traffic that needs routing. Access layer, only the traffic within the same VLAN. The core layer is to connect many distribution layers. So traffic from one distribution layer to another distribution layer, another segment, another part of the network is through the core layer. We also connect the internet to the core, internet. You see this picture. This is what I was explaining you. There are many segments. You see, this is one segment, this is another segment, this is another segment, this is another segment of your enterprises. To connect between all the segments, what do you have? Core layer. Core layer connects between all the segments. Each segment I have access layer, distribution layer. Access layer, distribution layer. Access layer, distribution layer. Access layer, distribution layer. This is where you're connecting to the internet. That's why we call it as edge distribution model. Edge of your network, the place where you connect to the internet. You see, this is the highly recommended, tested network design. Core layer, distribution layer, access layer. Core layer connects all the segments. This is one segment, this is another segment. So each segment has got a access layer and a distribution layer. To connect between all the segments, you have core layer. So only if traffic is going from A to B, the core layer will be used. If traffic is going from B to let's say C here, the traffic will actually go like this. It will be local switched if it is same VLAN. There will be a link actually between these two. They have not drawn it. Actually, there will be a link between the switches. If it is different VLAN, then traffic will come to the distribution layer, get routed to the destination C, which is in different VLAN. So distribution layer comes into picture only if these two guys are member of different VLAN. When they are in same VLAN, there is no need for traffic to come to distribution layer. They will be local switched like this within the access layer. So what we see here is because of this three-tier architecture, not all traffics are going to be processed by all the devices. Only some devices are involved in every traffic. As a result, the load is being distributed. Instead of this model, if you do like this, router, switch, router, computer, then for every traffic, all device will be involved. Then always all traffic will be processed by all device. That will not be a good design because the load will be heavy always. Here we are sharing the load. It's the same thing what I said. You have access layer, the end downward towards the south, where all the local devices are connected. Likewise, we have various segments are drawn here in the cloud. Each cloud is a segment. All this forms one network, one big enterprises. And to connect between the clouds, what do you have? Core. Don't think that this is enterprise, this is service provider. No. Because they draw cloud, you should not think that it is talking about service provider. No. It's not service provider. It's one big enterprises, one network, one office network with multiple segments. Each segment have got access and distribution, and all the segments are connected through one core. Okay, we were talking about edge. Here you see edge distribution mode. I told you edge is the place where we connect internet. That's what drawn here. This is the inside campus. This is the edge segment connecting to ISP A, B, C. These are all older technologies like frame relay, any transport over multicasting, point to point. These are all old technologies. Don't worry about this. Just focus on ISP and ISPP. You see, this is our access layer. They're connecting to distribution layer. Those distribution layers are connected to the core. Core is also connected to edge. From edge, we are connecting to ISP A, ISPB, etc. Don't care about these things. They're old technologies. Now, understand when we have a network, that network is used for various purposes. One, you may do some file transfer. Tell me what are the things that you will do using your network? What are all the things you do using your network? I told one, you do some file transfer, which is kind of traditional traffic, normal traffics. And then some updates on routing, some management traffics, you telnet, you SSH, some mission critical application traffic, meaning you have some applications running in your office which are time sensitive, mission critical. Some traffics are voice traffic generated by the application. Some are voice and video traffic, like what we are having now, Google Meet, voice and video traffic to listen to the class. To see the board, we use video. Yeah. Now you have different type of traffics. Not all traffics are equally important. Not all traffics are equally important. We have different types of traffic here. Some are very, very critical and important. Some are not. So what is needed? Performance. So you need to do some proper tuning, configuration, so that voice, video, mission critical traffic will be given high weightage, high preference, high bandwidth, so that there will be less delay or no jitter. What is jitter? A study delay is delay. If you have delay always same, then it is simple delay. If the delay is varying, then it is called jitter. For example, when you transfer a file, sometimes it goes in 10 milliseconds. Sometimes it takes 15 milliseconds. Sometimes it takes 100 milliseconds, which means it is not delay, it is jitter. Jitter means what? Uneven delay. Uneven delay. It's not constant delay. Uneven delay. So in an enterprises, though we got different type of traffic, some traffics are very small traffic, some traffics are huge. You see, when you transfer a file, the traffic is going to be huge. But when you are doing a voice call, the traffic is tiny. So you have to do some sort of quality of service to improve the performance of the network. Not only that, you need to have proper security to deny access to attackers, to provide access to genuine users. Right? So we need to focus on all these things when we talk about a network. This is old technology, forget about these things, not needed. So we got different routing protocols, OSPF, EIGRP, ISIS, BGP. We're going to learn all of this. RIP version 2, static. In a backbone where there is a huge network and big infra, then you will not use static route. When the network is small within the building, then you may use static route, right? So if you see here, there is a difference between three protocols listed. For very large network, only ISIS is used. For convergence, for very high convergence, you use EIGRP. Yeah. So you can go through these differences later in the video when you get it. Use of VLSM, all three supports. What is VLSM? Subnetted networks. Variable length, subnet mask. Mixture vendor, OSPF, ISIS. EIGRP is a Cisco protocol. So not many vendors know about EIGRP. You cannot have one router with Cisco, another router with some other vendor. Not possible. Right? So this chapter was just introduction to enterprises. Okay, the first protocol that we will focus is RIP. Routing Information Protocol, RIP. You might have learned this one many times in your past, like CCNA training and etc. Here we're going to have a quick revision. The protocol RIP is used in a small network. The reason is the number of hop count the RIP updates can go is maximum of 15 hops. That's the limitation. That's why this protocol is not for large network, large campus, large enterprises. It is not for large enterprises. It's for network advertisement within a building or within a small number of hops, like 10 hops or less than 15 hops. What is hop? Routing jump. Every router is one hop. To reach a destination, if I need to jump 5 routers, then it is 5 hop. For example, you see for router 1, to forward the packet to B from A, there are two paths. One path is this path, which has got 2 hops. 2 hops, you can reach B. The other path has got 1, 2, 3 hops. So if you go this way, it is 3 hops. If you go this way, it is 2 hops. If you choose this protocol RIP, it will see the hop count. It compares the hop count. The path with the lowest hop is taken as the best path. So the metric of RIP is hop count. Hop count. We were talking about the metric. Every protocol has got a metric. To decide the best path, they use the metric. For example, RIP using hop count. You see, to go from A to B, RIP will choose the upper path. This is upper path. This is bottom path. Why it chooses the upper path, can anyone say? Less number of hops. Correct. Less number of hops. See, we also choose the small one. For example, you're going from Frankfurt to Amsterdam. There are two flights. One is taking 100 euro, the other one is taking 300 euro. Which one you choose? 100 euro flight. Yes, it's the same distance. Why should I give 200 euro extra? So you also choose the small one. Same way, RIP is also choosing small is best. Smaller the hop count, better is the path. So metric always small is good. Hop count is the metric for EIGRP. Sorry, for RIP. Hop count. Hop count is the metric. And if an advertisement is going, it will send the advertisement only to 15 hops. We'll talk about that in detail later. Now, RIP has got a type called distance vector. Distance vector protocol. RIP is a distance vector protocol. Distance vector. Why? It shows the distance. What is the distance? 2 hop, 3 hop. And it shows the direction. If you go this direction, it is 2 hop. If you go the other direction, it is 3 hop. So it gives both the distance and the direction. That's why we call RIP as a distance vector routing protocol. Based on the distance, the direction is determined. RIP is a distance vector protocol. See, we got RIP as one routing protocol, EIGRP as another routing protocol. Which one has got more weightage, EIGRP or RIP? Which one has got more weightage? EIGRP. How do I say that? I say that by using the administrative distance. You see, the administrative distance is a numerical value to say how much weightage is given to this protocol. For RIP, the administrative distance is 120. You know, for EIGRP, it's 90. You see, the lower the number, more weightage. 90 is lower than 120. So if I am running RIP and EIGRP on a router, the router will only follow EIGRP, not RIP. Even though you are running both, whatever EIGRP gives as a route will be considered. The RIP given routes will not be considered because EIGRP has got more weightage. Smaller the number, more weightage. That is what we called as administrative distance. RIP's administrative distance is 120. EIGRP administrative distance is 90. OSPF administrative distance is 110. 110. ISIS administrative distance is 115. BGP administrative distance, we have two. One is IBGP which is 20. EBGP is 20. IBGP is 200. EBGP is 20. IBGP is 200. Right. So now the distance, administrative distance is 120 for RIP, and the limitation of RIP is 15 hops. The metric is hop count, and this RIP has got two versions. The default version 1 is class full. Version 2 is classless, which means this do not support variable length subnet mask. These don't support VLSM, whereas version 2 supports. Right. So this is just an introduction to RIP. We'll have another one class only for RIP. Administrative distance is used by the routers to decide which routing protocol to follow. If you have multiple routing protocols on same router, to decide which routing protocol's route to follow, it will compare the administrative distance of each protocol. The protocol with the lower administrative distance will be considered. For example, RIP is giving route to reach Yahoo. OSPF is also giving route to reach Yahoo. The router will choose OSPF. The reason is OSPF administrative distance is 110, whereas RIP administrative distance is 120. 110 is lower. Lower is preferred. Covered? Yeah. Fine then.